So hello, we have enthalpy change of combustion and Hess's law. So enthalpy change of combustion is delta CH, see it written up there in the corner. And you can see right, enthalpy change of combustion is the enthalpy change of 1 mole of a substance is completely combusted under standard conditions. That's your definition for your exam, so make sure you put it in your notes. We see 1 mole here of a substance that's being completely combusted has the right amount of oxygen to make the product. So we do half of this means 1 oxygen to make the 1 mole of water. It's an exothermic reaction that gives out heat. Okay, so exothermic reaction here, minus 2H6, gives out heat. So very important that 1 mole of a substance completely combusted, so right amount of oxygen under standard conditions. Let's move it to the side. Now, enthalpy change of combustion. Let's go through some examples and how you do it. So first of all, I said there, use halves as necessary when you combust 1 mole of the fuel or the substance only. Okay, so if a reaction takes place by more than 1 route, okay, the initial and final conditions are the same. The total enthalpy change is the same for each route. That is Hess's law. And hopefully before you come to this video, you have done this. Now, what does that mean? In every Hess's law video, we do this the same when we say what this means. So you can get reminders. So first of all, you have a reaction where you're going from A to B, and we'll call that enthalpy change delta RH, because it could be any reaction. So R just stands for reaction. And there is a video on enthalpy change of reaction if you want to look it up, and questions that relate to enthalpy change of reactions. Now, enthalpy change of reaction is just the energy change or enthalpy change for a given reaction. So this could be anything from A to B. Now, what we can do with Hess's law is we can make cycles. And the cycles mean that you can, if you're going from, say, C up to A, we'll call that delta 1H. And then we've got B to C. So that whatever B is, let's just say we've got an equation and it makes C. Let's just say we've got another equation and C makes A. That means we can join the whole thing together. So we can join this together, and the arrows go in certain directions because it'll go in the direction of the equations that you are given. And we'll go through examples of this anyway. This is just a general example. So that basically means if we've got the top one here, okay, what we do is we add all the arrows that are going in the same direction. So if we look here, we've changed these two, and you can see they're both orange, so they're going in the same direction. So we use it like a circle like this, and you can see that they are going in the same direction. That's going in an opposite direction. And therefore, 1 will equal R plus 2. So let's put that up on the board for you now. Okay, so 1 will equals R plus 2. So the ones that are going the same direction are added together. There are other ways of doing this. This is the simplest in my view, and I'm going through the simplest way of doing it. In the exam, you don't have to draw these. These will not get you marks in the exam, but this equation here will get you marks in the exam. But you use the diagram to figure out what's going on. Right, okay, let's rearrange that. So we've rearranged that basically so it equals R. So what we've done is taken the 1 away, okay, and there you go. Now another way of doing this is to make the 2 bottom arrows go in the same direction. You can do that by reversing this arrow, and that turns that into minus delta 2H. If that's the case and you reverse an arrow, and this turns into minus delta 2H, it still comes out with that one right there, and that equation right there. Right, okay, so there is our final expression, and that expression you then use with a question. So now we're going to go on and use it with a question. So we're now going to do our question, and all the questions on combustion are like this. So if you can do one, you should be able to do them all. There's another video on enthalpy changes of reactions, which can be a bit tricky. Okay, and please look at that one as well. And there's another one on enthalpy change of formation, which all have a specific way of doing it. But let's talk about combustion. So here is our equation, which you'll notice is an enthalpy change of formation. It takes the elements to the compounds, 1 mole of the compound. Okay, and it's part of a question. So the formation of this is in the following equation. Enthalpy change of combustion is shown in the table. So if we go down here, we know the enthalpy change of combustion because of the C. Okay, and here's our values. We then make a Hess's law diagram out of it. So we've just copied this part here and put it here. Okay, we've made 1 mole of our product. Let's get rid of the question. Okay, now, there we go. Okay, and then we've got 1 arrow going towards our combustion product. So combustion of carbon is carbon dioxide, combustion of hydrogen is water, And we just balanced it according to 2 moles of carbon, 2 moles of carbon dioxide, 3 moles of H2, 3 moles of water. We're just balancing up the hydrogens here and making sure they're the same. We then counted the number of oxygens and then added the extra oxygen here on the side. Now, the next one is to combust the ethanol. Now notice both arrows are going down, okay? So they're going down so they're being combusted to make these products. Notice when you add the oxygen, it's the same on each side, and they're going in opposite directions. They cancel each other out. Okay, so basically that's going down towards your product. So here we have 2 arrows going in the same direction. And all combustion questions are like this. If you have an enthalpy change of combustion, the arrows will point down. Okay, and you've got 2 going in the same direction. That's R and 2. That's going to equal 1. So R plus 2 equals 1. If you rearrange that, and hopefully you rearrange that in your head now, to equal R, you will get, okay, R equals 1 minus 2. Okay, so 1 minus 2. So all we now need to do now is put that up there, and we need to write out how to do the equation. And let's do this, shall we? Okay, give this a shake. Okay, and then first of all, we're going to do delta H1. So delta 1H. Delta 1H is going to be 2 times minus 394. Okay, now why is it 2 times minus 394? First of all, minus 394 is the carbon down here. We've got 2 moles of carbon, so that'd be 2 times that number. And then we've got 3 moles of hydrogen. See, put it there. Sorry, there. Okay, and it'd be 3 times minus 286. 3 times minus 286. Add that together, and we've got our 1. Now that will equal, on my notes here, that will equal a minus 1646. Then we're going to have 2. And this 2 is going to be the enthalpy change of combustion of this one. That's ethanol. Ethanol says minus 1367, so we just copy the number over. Okay, and then all we have to do is put it into the expression up here. So it's 1 minus 2. So that means the final answer to our question is R equals 1. 1 is that one there. So that is minus 1646 minus 1367. So 2 minuses make a plus. Okay, don't you just love maths? All right, okay, and then you add those 2 together, and then what you get is a final answer of minus 279. Okay, you can put the kilojoules per mole as the unit, but they don't ask for it normally, so I'm not going to bother. Okay, so basically this is it. This is how you do it for enthalpy change of combustions, for Hess's law, and questions like that. Okay, please. This will happen every single time in this way, and often it's a 1-mark question when it comes to A-level papers. If you do AS, some lucky people do AS, okay, then it can be more than that, okay? But these ones normally are quite quick, and if you've done them a few times, you'll get used to them. They're quite easy because you just quickly bang them out like that. Now, if you want to practice some of those, there'll be a worksheet attached to the video.